the run, this is the activity I chose that would be a best fit for my classroom based on the limitations that I have, and it is all about angles. The name of the activity is Playground Patterns of Cracks, and I found this at the exploratorium.edu website. What is expected is students are asked to go outside the school and walk around the campus and playground looking for cracks in the ground. And as they walk, they should document it by sketching it on paper. Now, for this activity, I took pictures so I could show some various cracks found from poles, across the sidewalk, from a draining system, and even buildings. So they should collect as many and sketch as many as they can on their paper. And it may look something like this. As you can see, there's some in open areas, sidewalks, poles that bird's eye view are just circles, and so on. Then they should use a protractor to measure the angles. The only difficulty students may have with this is poles, where to place their protractor. So for some of these, you can see I sketched an imaginary line here where the protractor would be placed to best get the angle. After they've done this, they should look at their drawing and see if they can notice any patterns of angles. What ones have in common, certain degrees that they see often, things with poles, how common the angles are for those. And they should draw some conclusions. So the conclusions I made are objects with corners that were like the drain and the building tended to cause cracks that were 130, 135 degree angles out from them. Poles or rounded objects had cracks that were at 90-degree angles. Some of mine showed 45 or even, I think, 35 or even 145. But those would, depending on how you rotate your protractor, could be argued at 90 degrees. Sidewalk cracks tended to cross at 45-degree angles, and open cracks that were unattached to objects are at 120 degrees or 60-degree angles. So discussion should be had about why this happens. Obviously, objects cause force into the ground and that pressure creates the cracks. So you can have a discussion about force and pressure in science class, which is a topic of our curriculum, which is also why I chose this activity. To extend off of this, you could have students discuss ways that we could prevent these cracks from the objects, so we're not just patching them all the time. It should also be discussed about these open area cracks, how that happens from weather, heat, and cold, the changing and expanding of these objects that cause the cracks. So this curriculum plan that I have is definitely based off of the interdisciplinary integration approach. I was able to integrate 2 disciplines based around a common skill or concept, which according to our class test by Vasquez, that describes interdisciplinary integration. So in mathematics, the essential question is how are angles formed and measured on concrete pavement? And in science, what patterns can be found in cracks developed by objects, and how does pressure or force create cracks at various angles in concrete? So looking at figure 8.7, this definitely fits all of the interdisciplinary categories here. It's all organized and developed around that main skill of angles. And the role of the disciplines is to practice and practice that concept of angles and measuring them and finding them. My role is to lead it and facilitate and assist the students with their findings as they walk around finding the cracks and measuring them. Their goal is to learn the skill of angles in both math and science with some moderate integration, and they are assessed by combining both the methods in math and science to measure those angles as they walked around and hopefully notice them in nature now more often. And the resources for this were from, again, the exploratorium.edu website and from our class text of STEM Lesson Essentials.